So our topic for today is all about leakage reactance. So what exactly is leakage reactance? So leakage reactance is produced from the leakage flux that link to the primary and secondary windings of the transformer. So what is leakage flux? So sabi dito, yung leakage flux daw defined as the magnetic flux which does not follow the particular intended path in a magnetic circuit. So, yung leakage flux, ito yung mga flux na kung saan hindi siya nag-follow ng particular intended path. Due to this leakage flux in the transformer, there will be a self-reactance in the conducted winding. This self-reactance of transformer is alternatively known as leakage reactance of the transformer. So, pwede nating matawag na self-reactance yung leakage reactance of the transformer dahil nga wala siyang sinusunod na path dun sa magnetic circuit. To help you understand better, so meron tayo ditong figure na kung saan may primary winding, may core, may secondary winding, may leakage flux, tas main flux. The main flux which will pass through the winding insulation and transformer insulating coil instead of passing through core. So sabi dito, yung leakage flux daw, sabi ko nga kanina, yung leakage flux, ito yung magnetic flux or flux na hindi nagpapalo ng particular intended path. So, dito sa figure na to, ito yung main flux natin na kung saan nagdadaloy siya into, or yung flux na is dumadaan dun sa pwedeng dun sa winding insulation or dun sa coil. Pero pag sinabi nating leakage flux, pwedeng dun sa loob ng core dito sa gitna or dito sa labas. Due to this leakage flux in transformer, both primary and secondary windings have leakage reactance. Mapapansin natin dito sa figure na to, yung primary winding and secondary winding, merong magnetic flux na hindi nagpa-follow ng particular intended paths. And ang tawag dun is leakage flux. This phenomenon in transformer is known as leakage flux or magnetic leakage. So, yung phenomenon daw ng transformer na pagkakaroon ng hindi nagpa-follow ng particular intended path dun sa magnetic circuit, ang tawag daw dun is leakage flux or magnetic leakage. Facts of leakage flux that have effect on leakage reactance. As the magnitude of the leakage flux increases, the magnitude of flux in the core decreases. So, sabi dito, as the magnitude daw ng leakage flux increases, the magnitude of the flux in the core decreases. Ang sinasabi dito na habang yung magnitude ng flux is dumadami dun sa leakage flux, maraming flux ang dumadaloy outside the core or dun sa labas ng both primary and secondary windings, ibig sabihin madidecrease nung yung mga flux na dumadaan dun talaga sa transformer insulating coil or dun sa winding insulation na kung saan tinatawag itong main flux. Leakage flux increases considerably as the current in the winding increases. Leakage flux travel through the empty space intended through iron, so no saturation, hysteresis, and permeability equal to mu0. So, sabi dito, na yung leakage flux nga is nagte-travel sa empty space, which is true naman. Dun sa, pwede siyang outside, dun sa both primary and secondary winding, kasi nga, hindi siya nagpa-follow ng particular intended path. Then next, does the leakage reactance important? Sabi dito, nagiging important daw yung leakage reactance kapag nagdi-design tayo ng transformer. It is because the leakage reactance is contributing to the voltage drop in both primary and secondary windings of the transformer. So, bakit ito importante sa pagde-design natin ng leakage reactance? First, yung nakaka-contribute siya ng voltage drop dun sa primary and secondary windings. Second is the leakage reactance is associated with resistance of the transformer producing the impedance. So, this impedance of the transformer is the main cause of the voltage drop. So, dahil daw sa leakage reactance, nagpo-produce tayo ng impedance, na kung saan yung impedance daw nung transformer, ito yung pinakadahilan kung bakit nagkakaroon ng voltage drop. Next is the magnitude of leakage reactance. So, designing considers the following parameters as magnitude of this reactance is a function of. So, sa pag-design natin, we consider the following parameters. Yun nga yung number of turns of the primary and secondary winding, the current in the winding, and the geometry of the core and windings. So, the effect of leakage reactance in power transformer. First, it reduces the secondary voltage under load. It limits short circuit currents. This is useful and consumes reactive power. So, basically, leakage reactance is just some sort of losses in the transformer system. Flow that should be eliminated. But is the leakage reactance can be eliminated? So, sabi dito, leakage in primary and secondary windings could be eliminated if the windings could be made to occupy the same space. Pero, this physically impossible. But by placing secondary and primary in a concentric manner can solve the problem in a good extent. So, leakage reactance can never be totally eliminated, but it can be reduced by some methods. So, yung leakage reactance daw, hindi natin totally siya ma-eliminate. Pero ma-reduce natin in some ways or some methods. Yun nga is yung keeping the space between the windings small. Ibig sabihin, yung space natin dun sa primary and secondary windings natin is paliliitan natin para wala gaano ma-produce na leakage flux. So, placing the windings as close as possible. Yun nga. Varying the winding dimension. Dito, leakage reactance daw is actually the fluxes have no real existence as they show up distortion or harmonic in the mutual or air gap flux. Dun sa reference na binigay ni ma'am, dun sa alternating current machines, meron akong nakita na topic about leakage reactance. Then, under ng leakage reactance, meron tayong slot leakage. Tapos, yung isa is end coil reactance. Tapos, meron pang isa, yung two-tip reactance. Pero, yung in-involve lang dun sa sa reference is yung slot leakage and end coil reactance. Sinasabi dito na slot leakage reactance daw and end coil reactance are the only two components which will be calculated. In addition, tooth-tip reactance is sometimes included. Pero dun sa reference nga, slot leakage lang. Tapos, yung end coil reactance. So, dito tayo sa slot leakage. When a conductor or series of conductors is embedded in the slot, current flow builds up a magnetic field as shown. So, sabi dito, kapag meron tayong conductors or series ng conductor na kung saan embedded siya dun sa slot, ibig sabihin, yung current niya is build up, or pwede din mag-collapse of this flux, pero nagbi-build up siya ng magnetic field. So, alternations of the current cause the building up and collapse of flux about the conductors, thereby inducing the winding as slot leakage reactance voltage. So, because of the alteration of the current, ito yung cause kung bakit nagkakaroon ng building up and collapse of flux about the conductor. So, next is the reluctance of the flux path will be considered for the air or copper only, neglecting the iron as being of negligibly small reluctance. So, sa pagsisolve natin ng reluctance dun sa flux, kino-consider natin lang sa air or copper. Kasi kapag kinonsider natin dun sa iron, is magiging small lang yung reluctance and parang binabaliwala na lang yun. So, meron tayo dito null sub L, which is the leakage flux line per ampere per conductor per inch of slot length. Then P is the number of poles. B sub O is the conductors in the series per slot. S1 is the number of stator slots. L is the gross length of the core in inches. And QS is the slots per pole containing phase conductor in series. So first, what do you mean by reluctance? So sabi dito, ang reluctance daw is the property of the magnetic circuit of opposing the passage of magnetic flux line equal to the ratio of the magnetomotive force to the magnetic flux. So, the leakage flux per slot per ampere is then null sub L times BO. Sinabi nga, yung null L is the leakage flux line per ampere per conductor per inch of a slot. Then, times L, which is the gross length of the core in inches. Then, B sub O, ito yung the conductors in series per slot. If each flux line link every conductor in the slot, the linkage per slot per ampere would be. So, kapag daw yung slot natin is nakaka-linkage per slot per ampere, ibig sabihin mai-squared yung conductor in series per slot na kung saan ayun nga. Same din siya dun sa leakage flux per slot per ampere. Yun nga lang naka-squared nga yung conductors in series per slot. So, since each phase has QS, which is the slot per pole containing phase conductor in series, the reactance of the winding for the slot leakage flux is then, so ang magiging formula na natin dun sa slot leakage flux ng reactance magiging is equal to 2 pi f times the leakage flux lines per ampere per conductor per inch of slot length times the conductors in series per slot squared times the number of poles times the slot per pole containing phase conductors in series times 10 raised to negative 8. And ang unit natin dun sa slot leakage reactance is ohm. Each flux line does not link each conductor or element of one conductor in slot. This fact is considerably by using a slot constant which expresses the ratio of effective linkage to actually linkages. So, meron tayong slot constant. Referring again to figure 56, it will be assumed that the slot is full of conductors or contains one large conductor that carry uniformly distributed current. The latter assumption is not quite correct in practice. The flux distributed from top to bottom of slot is linear, but the interlinkages will be parabolic. Since the average height of the parabola is 1/3 of its maximum value, the same result is obtained as though the effective area of the flux path were 1/3 times BC, which is yung BC natin is the slot dip times Asia length of the slot. A more rigorous analysis can be made for the above, holding for sloping slot sides or any other shape than straight slots by using elements of slot dip and the summation by calculus. So, permeance. Permeance of air is proportional to the area divided by length of path and to use inch unit. So, pag natin, nasa inch, we then would have a permeance of the slot leakage flux path. So, formula natin ng permeance of air is permeance is equal to 0.4 pi times 2.54 times 1/3 times slot dip all over the slot width. So, 0.4 pi times 2.54 magiging 3.19 BC all over 3 times A per inch of Asia length. So, the constant 0.4 pi inherent with the magnetic circuit from the system of units used will be absorbed with the permeance rather than with the ampere turns. The slot constant Ks will then be defined as the value of BC all over 3 times A, and it holds only for this last shape. The previous expression from the slot leakage reactance involved flux lines. We will know that they are equal to 3.19 Ks for each inch of Asian slot length. But as used in engineering offices for many years, this theoretical value of 3.19 is increased to 4.2 simply because it has shown the result consistently to greater accuracy. So, instead daw na gamitin natin yung 3.19, ang gagamitin natin is 4.2 para maging accurate yung pag-solve natin nung sa permeance. Furthermore, if S1 equals to the total stator slot and there are m phases, the slot per phase are S1 divided by n. So, ang S1 natin is a total stator slot. Ang m natin is phases. So, yung magiging slot per phase natin is S1 all over m. Then, yung natin, B sub OP times QS, ito na yung magiging total series conductor phase per phase natin na kung saan yung symbol niya is C. Ayun nga, per phase which has represented by the symbol of C. Then, for the core length of L inches, yung L natin, which is the gross length of the core, dapat naka-inches siya, or naka-inch. So, ang magiging value na natin ng slot leakage flux, or yung X slot, is equal to 2 pi f c squared m times 10 raised to negative 8, the quantity of 4.2 times L times Ks over S1, which is ohm per phase. The above equation assumes that all conductors are carrying current in time phase. So, ina-assume natin na lahat ng conductors is nagkikarry ng current in time phase. On double layer winding, the fact that one coil side is in the top and one is the bottom of the slot would modify the individual effects, but the average would be shown. For fractional pitch winding, if the pitch is such, the result in the phase displacement of degrees between sides 1 and 2 of a coil, then coil side 2 will be in a slot with another coil with whose conductors are carrying current degrees ahead of the current in 2. So, the out-of-phase component of the voltages induced by the leakage flux will be cancelled out, but in phase component will be reduced. This result is less reactance drop with the apparently less reactance. Such effect is considered by correction for the pitch designated Ks. Value can be found in Alger paper on this subject as well as in early work of Adams in induction motor leakage. In their simplest form, they are fundamentally the same. So, values of Ks for pitches of 0.5 to 1.0 can be expressed as, so sa pitch natin is 0.625 times P plus 0.375 na kung saan yung P natin is the pitch as a decimal. So, yung P natin dapat nakadecimal sa pag-solve. So, next is the end connection leakage. Dun sa end connection leakage natin, meron tayong permeance of the air path which is equal to rho over 2p. Ang kung saan magiging formula natin ng end connection leakage is equal to 2 pi f times C, which is the total series conductor per phase times m squared. Yung m natin is phases kung saan naka-squared, times 10 raised to negative 8 times yung the pole pitch natin na naka-inch over 2 times P, na kung saan yung ano natin, 'di ba, permeance of the air path, yung rho over 2p, then times KE. Yung K is a construction constant influenced by the placement of the coil and the various other factors mentioned. Yun nga yung KE natin. So yung KE natin is equal to 0.25p minus 0.25. Ginagamit natin to sa pitches sa end connection leakage. So, ma-example tayo sa pag-calculate ng armature leakage reactance. To illustrate the method, we will use the data from the same machine for which armature reaction was just calculated. So, may mga given tayo. Series conductor per phase is equal to 240 slot width is equal to 0.504 inch, slot depth is equal to 2.5 inch, pole pitch is equal to 6.024 inch, axial length of stacking is equal to 4.5 inch, number of stator slot is equal to 144, phases is equal to 3, pole is equal to 24, and pitch is equal to 5/6 or 0.833. Slot constant natin is 1.65. So, pag-calculate muna natin ng slot leakage. So, 2 pi f, 'di ba may formula tayo na 2 pi f c squared m 10 raised to negative 8 times the quantity of 4.2 lks over s sub 1. So, ayan na, 2 pi f times 240 squared times 3 times 10 raised to negative 8 times 4.2 times 4.5 times 1.65 over 144 or 0.140. Then pag-calculate naman natin ng KS, ito yung sa pitch natin. So, 0.625p plus 0.375 ay yung p natin is, diba dapat nakadecimal siya, so 0.833. So, magiging sagot natin is 0.895. So, ang ano natin, leakage slot or slot leakage is 0.140 times the pitch, which is the 0.890, which is equal to 0.1255 ohm. For ano to? 5/6 pitch. 5/6 pitch. Then next is we will solve for end connection leakage equation. Equation natin sa end connection leakage is x end is equal to 2 pi f times, di ba pag solve natin nung sa end connection leakage is equal to 2 pi f cm squared times 10 raised to negative 8 times times natin dun sa permeance ng air path times KE. So, substitute na natin 2 pi f times 240 squared times 3 times 10 raised to negative 8 times the quantity of 6.024 times 121 times 0.79 all over 2 times 24. So, ang magiging sagot natin is 0.079 ohm. So, the value of 0.79 then sa correction of pitch natin dun sa end connection leakage magiging kasi ang baga natin sa pitches nung sa end connection is 1.25 p minus 0.25. So 5/6 yung pinatan, which is the pitch, which is equal to 0.79. So the total leakage reactance, ang magiging total leakage reactance niya is isasam lang natin yung dalawa, yung slot leakage tapos yung end connection leakage. So ipapag plus natin, ang magiging total leakage reactance niya is 0.2045 ohm. So sabi dito, this is smaller than the Pottier reactance calculation for the same machine. Kasi sa previous pages nung sa reference, sinunod muna yung Pottier reaction na kung saan inano nila kinumpare, mas smaller daw yung value ng total leakage reactance kaysa dun sa Pottier reactance. Yun nga, sa pagsisolve natin ng leakage reactance, ipag-add lang natin yung slot leakage and the end connection leakage. So, ang reference natin is yung leakage reaction by Shariful-Apike and alternating current machines by A.F. Backstein and Tessiloid. So, that's all and thank you.